This is Divyasri from Civil Department, and this is my CA2 assignment of power systems. This is my second BTech and second semester. And CA2 assessment of power systems. Topic is explain how single core and three core cables or capacitance is calculated. Capacitance of cables are two types: capacitance of single core cable and capacitance of three core cable. First, we will see about capacitance of single core cable. A single core cable functions as an electrostatic capacitor as it consists of two electrodes. First one is the core and the second one is the sheath separated by dielectric material. This is the diagram of the capacitance of a single core cable. The two components, the core and the sheath separated by dielectric material. Let lambda represent the charge per unit length. By definition of capacitance is the ratio of charge only one on electrode to the potential difference between the two electrodes. Therefore, C equals to lambda by V. Before the C equals to lambda by V, lambda here V equals to lambda by 2 pi epsilon natural log of capital R by R. Lambda equals to 2 pi epsilon by natural log of R by capital R by smaller. Here lambda will be cancelled. The 2 pi epsilon will go upside, and therefore 2 pi epsilon by natural log will convert into the log. It will known as a 2.303 log base 10 capital R by R Faradays per meter. This is the unit. Therefore, the capacitance C equals to 2 pi E epsilon 2.303 log base 10 capital R by smaller. Epsilon by 41.4 log base 10 capital R by smaller 10 to the power of minus 9 Faradays per meter. Here, if the cable has a length of L meter, the capacitance will be if the cable has a if the cable has length, then the formula will be capacitance E equals to epsilon or L by 41.4 log 10 capital R by smaller 10 to the power of minus 9 Faradays. Here L will be the length will be calculated by this formula. If the cable has a length meters, by this formula capacitance will be calculated. In three-core cable, and this is a three-core cable, and in the three-core cable the sheath is maintained at potential while the three conductors are at their respective supply potentials. This configuration results in the information of 6 capacitance. 3 capacitance exist between each conductor and the earth sheeted, while the remaining 3 capacitance form between the conductors themselves. There are 6 capacitance: 1, 2, 3, 4, 5, 6. First capacitance, second, third, and fourth, and fifth, and there are 6 capacitance are there here. And the 3 capacitor exists between each conductor. 3 or exist between each conductor. 1, 2, 3. And the earth sheet, well, the remaining 3 capacitor between the conductors. And the conductor exists between the conductors, and these 3 are between the earth conductors themselves. Here is the delta connector system. It is middle part of the system, middle part of the conductors. Delta connected capacitance formed between the conductors. The delta connected capacitors are formed between the conductor is known as delta connected capacitance. Is converted into equivalent circuit star network. See the equivalent circuit of star network. See the star point is at the same potential as a sheet, and the entire capacitor can be effectively reduced into equivalent star. The delta connected system is equivalently reduced to the equivalent star connected system by if the two capacitors are in parallel, and these two capacitors are in parallel, and these two capacitors are in parallel. But in capacitor, we can when the two capacitors are in parallel, we can add the two capacitors. If C0 equals to C1 plus 3C2, C0 equals to C1 plus 3C2, and C1 plus 3C2. If we convert the equivalent star connector system, the circuit will be like this. The two parallel resistors are combined one resistor to form C0 equals to C1 plus 3C2. The two unknown capacitance C1 capacitance between each conductor and the sheath, and C2 capacitance between the conductors to need C1 is a capacitance between each conductor, C2 is a capacitance between the conductors that need to be determined to find the capacitance per phase of the cable. To obtain these values, the following measurements are required. First measurement CX. The three conductors are bunched together and the capacitance between the bunched conductors and the sheath is measured. The capacitance equals Cx equals to 3C1. When the conductors are bunched together and the capacitance between the bunched conductors and sheath measured as Cx equals to 3C1. And this is the capacitance of three-core cable circuit diagram. See, here the three capacitors are between the conductors, and these are earth sheeted conductors, and this the distance between the point and the core is the Cx, and this is connected to the ground. And the second measurement is Cy. The first measurement is Cx, and the second measurement is Cy. If the two conductors are connected to the sheet, if the two conductors are connected to the sheet, and the capacitance between the remaining conductors is measured by the Cy equals to C1 plus C1, C1 plus C2. The formula is Cy equals to C1 plus 2C2. The two conductors are connected to the sheet and the capacitance between the remaining conductor and the sheet is measured as the Cy equals to C1 plus 2C2. By this we can measure the Cy. The C0 equals to C1 plus 3C2 and the C0 equals to Cx by 3 plus 3 by 2 into Cy minus Cx by 3 equals to 3 Cy by 2 minus Cx by 6. So we can write 3 Cy minus Cx by 3. Note, in cases where the test measurements of Cx and Cy are unavailable, if the Cx and Cy are not available, we can conclude as C0 equals to 0.0299 epsilon r by natural log of 1 plus capital T plus small t by small d into 3.84 minus 1.7 small t by capital T plus 0.52 into t square by capital T square microfarad by kilometers. By this formula, we can calculate the C0 while Cx and Cy are not available. Where the epsilon r equals to relative permeability of dielectric material and the average value of 3.5. The d is the conductor diameter, small t equals to belt insulation thickness, and capital T equals to conductor thickness. The capacitance of three-core cable is a measure between any two conductor sheaths is 0.19 microfarad by kilometers. We have to determine the star connected capacitance in kVA. The supply we given is 20 kVA and 50 Hz supply. The given data is capacitance between any two conductors or 0.19 microfarad by kilometer. Supply voltage is 20 kilovolts and frequency is 50 Hz. Therefore, we can calculate the capacitance between the two conductors per phase is the formula 2 into 0.3.04 equal to 6.08 microfarads. Three-phase kVA required is V square C omega minus equals to V square C omega means 2 pi F. If we can substitute the values in the formula, we can get 764.342 kVA. And another problem, a three-phase three-core metal sheet cable gave the following results on the test. On the given data, this is a problem. The capacitor, we have to find out the two solutions. Capacitance between the two conductors bunched the sheet and the third conductor is 0.4 microfarads. Capacitance between the bunched conductor sheeted is 0.625 microfarads. The given two bunched conductors and there are three connected. We have to find out the two conductors values. One conductor value is 0.4 and another one is 0.625. Have to determine the capacitance and between two conductors and sheath, any two conductors, and calculate the charging current per phase per kilometers. Given the supply is 10 kilovolts per 50 Hz supply. Given data capacity between the two conductors bunched and the third conductor Cy is 0.4 microfarad per kilometers and the Cx value is 0.625 and the supply voltage given is 10 kilovolts and 50 Hz supply. Capacitance between any two conductors or sheets C1 equals to Cx by 3. We have the formula value Cx equals 0.625. We'll substitute, we get the 0.208 microfarad per kilometers. And we have to find out C2. To find out C2, we have one formula Cy minus C1 by C2. We got the they given the Cy value and we find out the C1 value. We can substitute the values in that. We get 0.096 microfarad per kilometers. The charging current per phase per kilometer is V by root 3 omega C naught into 10 cube amperes. Omega is nothing but 2 pi f. Voltage they given and the C naught also they give it. C naught we have to find. C naught means C1 plus 3C2. We can sub C1 or C1 we find out 0.208 and C2 equals to 0.096. We can substitute all these values in that we get the answer 0.899 amperes. So this is about the how the capacitance will be calculated of three core conductors and two core conductors. Thank you.